Technology forecasting. Learning objectives. List the elements of a good forecast. Outline the steps in the forecasting process. Describe at least 3 qualitative forecasting techniques, and the advantages and disadvantages of each. Compare and contrast qualitative and quantitative approaches to forecasting. Briefly describe averaging techniques, trend and seasonal techniques, and regression analysis, and solve typical problems. Describe 2 measures of forecast accuracy. Describe 2 ways of evaluating and controlling forecasts. Identify the major factors to consider when choosing a forecasting technique. Forecast. A statement about the future value of a variable of interest such as demand. Forecasting is used to make informed decisions. Long range. Short range. Forecasts affect decisions and activities throughout an organization, such as accounting, finance, human resources, marketing, MIS, operations, product or service design. Uses of forecasts. Following are the uses of forecasts. In accounting: cost or profit estimates. Finance: cash flow and funding. Human resource: hiring, recruiting, and training. Marketing: pricing, promotion, strategy. MISIT is systems, services. Operations: schedules, MRP, workloads. And in product or service design: new products and services. Features of forecasts. Assumes causal system, where past equals future. Forecasts rarely perfect because of randomness. Forecasts are more accurate for groups versus individuals. Forecast accuracy decreases as time horizon increases. Elements of a good forecast. Timely, reliable, accurate, meaningful, written, and easy to use. Steps in the forecasting process. Following are the steps in the forecasting process. Step 1: Determine purpose of forecast. Step 2: Establish a time horizon. Step 3: Select a forecasting technique. Step 4: Obtain, clean and analyze data. Step 5: Make the forecast. Step 6: Monitor the forecast. Types of forecasts. Judgmental, uses subjective inputs. Time series, uses historical data assuming the future will be like the past. Associative models, uses explanatory variables to predict the future. Judgmental forecasts. Executive opinions. Salesforce opinions. Consumer surveys. Outside opinion. Delphi method. Opinions of managers and staff. Achieves a consensus forecast. Time series forecasts. Trend, long-term movement in data. Seasonality, short-term regular variations in data. Cycle wave-like variations of more than 1 year's duration. Irregular variations, caused by unusual circumstances. Random variations, caused by chance. Forecast variations. Following on-screen figure shows forecast variations in trend, cycles and seasonal variations. Naive forecasts. The forecast for any period equals the previous period's actual value. Naive forecasts are simple to use, virtually no cost, quick and easy to prepare, data analysis is non-existent, easily understandable, cannot provide high accuracy, can be a standard for accuracy. Uses for naive forecasts. Stable time series data. F, t, equals a, t minus 1. Seasonal variations. F, t, equals a, t minus n. Data with trends. F, t, equals a, t minus 1, plus a, t minus 1, minus, a, t minus 2. Techniques for averaging. Moving average. Weighted moving average. Exponential smoothing. Moving averages. Moving average. A technique that averages a number of recent actual values, updated as new values become available. Ft equals man equals a, t minus n, plus so on, plus a, t minus 2, plus a, t minus 1, divided by n. Weighted moving average. More recent values in a series are given more weight in computing the forecast. Ft equals wman equals wna, t minus n, plus so on, plus w, n minus 1, a, t minus 2, plus w1a, t minus 1, divided by n. Simple moving average. Following on screen graph shows the graph of actual MA5 and MA3 series. Ft equals man equals a, t minus n, plus so on, plus a, t minus 2, plus a, t minus 1, divided by n. Exponential smoothing. Ft equals f, t minus 1, plus alpha of, a, t minus 1, minus, f, t minus 1. Premise, the most recent observations might have the highest predictive value. Therefore, we should give more weight to the more recent time periods when forecasting. Ft equals f, t minus 1, plus alpha of, a, t minus 1, minus, f, t minus 1. Weighted averaging method based on previous forecast, plus a percentage of the forecast error. A minus f is the error term, alpha is the percent feedback. Example 3, exponential smoothing. Following on screen table shows an example on exponential smoothing. Picking a smoothing constant. On screen figure shows the graph between demand and period. Graph is plotted for actual, alpha equals 0.4, and alpha equals 0.1. Common nonlinear trends. Following on screen figures shows the parabolic, exponential and growth curves. Linear trend equation. Ft equals a plus bt. Where Ft equals forecast for period t. T equals specified number of time periods. A equals value of Ft at t equals 0. B equals slope of the line. Calculating A, and B. B equals n sigma ty, minus, sigma t, sigma y, divided by n sigma t square, minus, sigma t square. A equals sigma y, minus, b sigma t, divided by, n. Linear trend equation example. Following on screen table shows the example of linear trend equation. Linear trend calculation. By substituting the values in the linear trend equation, we get y equals 143.5 plus 6.3 t. Techniques for seasonality. Seasonal variations. Regularly repeating movements in series values, that can be tied to recurring events. Seasonal relative. Percentage of average or trend. Centered moving average. A moving average positioned at the center of the data, that were used to compute it. Associative forecasting. Predictor variables, used to predict values of variable interest. Regression, technique for fitting a line to a set of points. Least squares line, minimizes sum of squared deviations around a line. Linear model seems reasonable. A graph is plotted for the given values of x and y. From the graph it is obvious that a straight line is fitted to a set of sample points. Linear regression assumptions. Variations around a line are random. Deviations around a line normally distributed. Predictions are being made only within the range of observed values. For best results, always plot the data to verify linearity. Check for data being time-dependent. Small correlation may imply that other variables are important. Forecast accuracy. Error, difference between actual value and predicted value. Mean absolute deviation, MAD. Average absolute error. Mean squared error, MSE. Average of squared error. Mean absolute percent error, MAPE. Average absolute percent error. MAD, MSE, and MAPE. MAD equals sigma, actual minus forecast, divided by n. MSE equals sigma, actual minus forecast whole square, divided by n minus 1. MAPE equals sigma, actual minus forecast, divided by actual multiplied by 100, whole divided by n. MAD is easy to compute and weights errors linearly. MSE squares error, and more weights to large errors. MAPE puts errors in perspective. Example. Following on-screen figure shows the example to calculate MAD, MSE, and MAPE, using the corresponding formulas discussed in the previous slides. Controlling the forecast. Control chart. A visual tool for monitoring forecast errors. Used to detect non-randomness in errors. Forecasting errors are in control if all errors are within the control limits. No patterns, such as trends or cycles, are present. Sources of forecast errors. Model may be inadequate. Irregular variations. Incorrect use of forecasting technique. Tracking signal. Tracking signal. Ratio of cumulative error to MAD. Tracking signal equals sigma, actual minus forecast, divided by MAD. Bias, persistent tendency for forecasts to be greater or less than actual values. Choosing a forecasting technique. No single technique works in every situation. Two most important factors. Cost. Accuracy. Other factors include the availability of historical data, computers, time needed to gather and analyze the data, and forecast horizon. Operations strategy. Forecasts are the basis for many decisions. Work to improve short-term forecasts. Accurate short-term forecasts improve profits. Lower inventory levels. Reduce inventory shortages. Improve customer service levels. And enhance forecasting credibility. Supply chain forecasts. Sharing forecasts with supply can improve forecast quality in the supply chain. Lower costs. Shorter lead times. Gazing at the crystal ball, reading in text. Exponential smoothing. On-screen figure shows the calculation of MAD and MSE, and the graph between actual and forecast. Linear trend equation. On-screen figure shows the calculation of MAD and MSE with slope and intercept, and the graph between actual and forecast. Simple linear regression. Following is an example of simple linear regression, and the graph between Y and forecast.